Howdy everyone, this is Ben, and today I'll be discussing how to do high tide problems at a given time. In this video, I will also be discussing how to read the tide tables in the reprint, when to use each table, how to correctly calculate the time based on the meridian, how many decimals to use, what do the symbols mean. You will need a few things to do this correctly. The tide table 3. Tide table 3 is found on page 109, and I highly suggest printing this out. This is very helpful to having a printed copy out. You can do it while in the PDF form. It's just a little is you have to actually with your fingers go and up and down the chart just to find. You will also need you need the problems, so I recommend having this PDF up with all the problems. Today I'll be doing a problem 447, as I feel like I have the most adequate notes for that problem, and it does cover a lot of bases, high tide problems, and the high tide form that Commander Wilson out. Once you have all these three things, you need keep the Terranave 2 additional problems on the PDF, but the high tide you sadly do need. So I will be going back and forth between this camera right here, which has the printed out tide form, which I will be filling out throughout this video while I'm explaining on what the tide tables do. So we'll start with the problem 447. So when we go to the additional problem, we see number 447. Write down the given information. 447, it says on the date of 27 April 1983. Don't worry, all of these are in 1983. Every single problem. Don't worry, need to worry. And the time desired is 11:05 EST. DD plus 4. And will be you need to predict the height at Falkner Island, Connecticut. This is all very good information, and everything here can solve the problem. So let me show you what I have so far. So currently I have the date and the time desired, but we need to account for a couple. So DST simply stands for daylight savings time. So we need to say yes. That means plus 1 hour. We'll be getting to that later, but you need to make sure you have this box circled. Remember what it means, daylight savings time. Then the rest of it, you need to look in the book. So now that we have this down, we're going to, right, typically we would use the index, find the proper substation number, then we would go with the tide tables that have listed numerically from 1. But since we are using the PDF due to the coronavirus, we have this option. So what I'm going to do is go to the first page, hit Control F on this, and I'm going to paste in what I just copied over from, and hit Enter. Hit Enter. It gives me a substation number and a bunch of information that I will need. So what all information means is this is the substation number, which I'll be writing in the substation box, and that'll be 19. This is the latitude and longitude of the substation. The time differences, this is the high water time difference. The next column is the low water time difference. This column is the high water height difference, and this column is low water height difference. This is the ranges, and this is the mean time. We for this problem will not be using these. Simply be using this problem, this column. So now that we know that information, we need to write down the high water differences for island. But there's a box below above that that says reference station. The reference station simply means refer to this right here. You can see throughout this that for New Orleans is all different reference stations. That is a main place where all of these are based off of this station's numbers. So that's why we have correction factors below, because it's not all, we can't have hundreds of reference stations, because that would just be hard to do throughout the world. So at Bridgeport is our reference station. Bridgeport. And we're going to copy down the page. It says PB48. Sadly, you can't put this into the PDF document as the pages don't line up. But what we can do, I'll show you how to find that decently. And then we're gonna go over to here, and we're gonna see the high water difference is a minus 0 hours 13 minutes. And let me show my. So I'm working on this one right here. So, and then the next line is low hour difference, which is a negative 0 hours 27. Next box says minus 1.3 feet. That's the high difference. And the low hour high difference, 0. So this is currently what my page looks like. I haven't really added any, just got all the given information down. Now, thing I forgot to add, which all the information right here, able to. Here, table 1. This through, I'll put slash given on. This is all found. But more importantly, we'll get to all those later. I just want to, just for an outline, what art means. Makes it kind of easier. Now that we have our correctional factors that are given in table 2, we want to go to Bridgeport on page 38. That gives us. So we're supposed to be safe. Table 1 is at the first third of the book. Table 2 is in the next third, and table 3 is in final third. Table 3, simple, you have to print out. Table 1, it would be improbable to print out. Trust me. So I'm just going to go to the page that I already found for this video. And when you get to this is page 48. I just saved some time. And then it says Bridgeport, Connecticut, like we're looking for on our paper, and the times for each month and day. So we're looking for April. January, February, March don't meet that criteria, so we'll go down to April. So April, and then now that we have April, when you go to the 27th, right? Copy that all down. And before I do that, zoom in just so you guys. All right. Now that we have that information, this is what we're going to be doing the full problem based on these references. Okay, so the reference station has we're trying to find for 1105. So 1105, if we add in, we have to add in 2 different factors. One, the high water time difference and low water time difference. But then we also have to add the fact that this is daylight savings time. This is where that really comes in. So, reason this comes in place, I'll try to explain it. But all of the meridians for the time are done based off of 1 ZD time. It's done off based off ZD plus 5. So ZD plus 5 is what generally most of the problems are done off of. And I'll go to page 89 just to show you. So So right here it says time meridian 75 degrees. So 75 divided by 15, as we found from the EA problems, is 5. DD5. That kind of makes sense. So most all of these are on time meridian 75 west. DD plus 5. What that means. So you have to make sure you account for that if it gives you anything different. So in a problem, it says daylight saving time ZD4. Well, daylight saving time ZD plus 4 is simply 1 hour added to ZD plus 4. Because daylight saving time, wait an hour, so add an hour back. So this would theoretically, daylight saving time ZD plus 4 be the same Eastern Standard Time 5. So, but we still have to account for that fact within the problem. So, we're going to go back to page 40, 41, go down to 20. All right, this information. Just make it easier. So, move it over. Now that I have my actual work, we're gonna account for all this stuff. So the fact that it gives you 0508, you have to account for 1 hour daylight savings time, hours you use, and 1105 has to be between the 2 hours you calculate. So 0508 is a low water tide because it's lower than the other two, 6.9 and 7.6. One more thing to add, I forgot to stress on this earlier. Ever use the right side of the column, unless you transfer to a maritime academy somewhere else in the world. We are in America, though, where we use feet. This is meters, not the right side column. Only use the left side. Never use the right side. Repeat that one more time. Only use these two columns right here. Never use the right column. Now that we've understood that, now we can start accounting for it. So, when you account for everything, you see that you have to subtract time from these two right here. But when you add in that extra hour of daylight savings, these two right here should be between it. Now, when I first did this problem, I just had to guess and check. That's why it gives you multiple boxes, so you can account for all this stuff and see which time the subsection will be between. So, but you can pretty much tell it's going to be between these. But if you're ever confused, write down all of them, and you'll never be disappointed. So, since 0508 is a low water time, I'm going to put that right there. So the time is now 0608 because I had to add in 1 hour daylight savings time where you account for that 1 hour. Then instead of 11:15, it'd be 12:15. Then station height does not change now, so it would be -2 and +6 points. Now that you know this, you need to account for these two things that I gave you. Reference station, these two things, height. So 0608 minus 27, 05, 68, 68. I'm doing this on my calculator, by the way. Minus 27, 41, 05. And then that'd be low water, and high water, the other number, be 18 minus 13 minutes, which here. Now that you have both those numbers, those are the numbers with the accounted for substation time. So we're going to put that simply over 0531 and 12, 2. Now we need to account for the heights. So the heights are pretty easy. All you have to do is on the low water, just do the sign that gives you. If it's a minus sign, you subtract it. Plus sign, you add it. And if it's an asterisk, which you will get in some of these problems, multiply it. So what I'm going to do for low water is, since the low water height is nothing, we're just going to be and 6.9. Since the high water difference is minus 1.3, we do 6.9 minus 1.3. We get 6. Now that we have this, we can start solving for the final third of the problem. That is these 3 items right here, or these 4, 5. So this is the last part of the problem right here. But it's actually pretty simple, so don't be... So 1202. We're going to find the duration of rise and fall. All I have to do is subtract the high water from the low water. Just the difference between how long it takes for it to rise to. So 1202, this 051, the 11, 2, and then we would subtract that from 41. We get 21. 11 minus 5, simply 6. 20. Time from nearest tide. Now, the time from nearest tide, we can safely assume that 1202 is closer than 1105 than 0541 is. If you ever want to know what is closer, simply get the number and take the larger number and subtract time desired from it, and take the lower number and add it to the time. You'll find out which number is closer. I might have done a couple that sign that messed up. You take the large number and subtract the time desired, and you would take the time desired and subtract the lower number. So in case you want to find that for future reference, you don't really need to on this. So the time from nearest tide is simply 1202 minus 1105. Then when you subtract that, 11, this is 62. 62 minus 5, simply 57. 1 is 0. 57, so 0 is 0. 7. You don't have to use this hour for minute format. I just think it's range of tide. So how you traditionally do range of tide is 5.6 minus a negative of 1.2. So simple math shows you 5.6 plus 2, which nets you 6.8. So the height of the nearest tide is simply which number you are using right here. So height from nearest tide is 1202. So the height of the nearest simply what the height of 1202 is, which is 5.6. So now we need to use table 3. So we will use these 3 inputs right here to find out what we need to do for table 3. Like I said, I printed out a copy of table 3 just because it simplified my life immensely. So if we look at table 3, it has a few different factors. Duration of rise and fall, and from nearest height, nearest high water or low water, and range of tide. And down right here is all the correctional factors. But we need to account for all 3 of those pieces of information that we figured out. So let's go in order. Duration of rise and fall is 6 hours and 21 minutes. Hopefully you were copying that down. So 6 hours is close. 6 hours 21 minutes is closer to 6:20. Use that. Let me try it. Hard. So 6 hours and 20 minutes. Now, tide from the nearest high water, which is 57. Now, for this problem, 57 actually lies right between 51 and 103. One of the answers will give you the correct Coast Guard answer. Since it's right in the middle, we're simply just going to use which one will get you the correct Coast Guard answer, which is 51. On the test or quiz, the leeway of this problem will account for the fact if you use the wrong, because I did both ways and I was only 0.2 off the correct answer. So 51, and then we go down to the range of tide. The range of tide that we just figured out was 6.8, so we'll round that up to 7. So round that up to 7, and we measure this column too, so 7 going across, and where that intersects with this going down is 0.3. Both of those articles, so 0.3 is our correctional factor from table 3. So again, just to go over, we use 3 item piece of information that we found right here: duration, range, to go from duration, go over to time, go down that column to range. Since hopefully it does. If you have any questions, please let me know. About answer. So now that we have that, and our correctional factor is 0.3, the height of tide at 05 is simply put our correctional factor with I have the nearest tide. But we need to know one more thing. Bottom of table 3. So right here in these bottom two sentences, it says when the nearest tide is high water, subtract the correction. When the nearest tide is low water, add the correction. Well, our nearest tide is high water, so we know to add. So we know to subtract 5.6 minus a correctional factor of 0.3. Subtract that. 3. Height of tide, 05. We go back to the additional questions on the page. Correct Coast Guard answer is 5.3. Hopefully this video has helped you solve high tide problems, and it has explained to you how to explain to you 3 tables and the preprints of the tide table. Please let me know if you have any further questions.